This one, if I take out my highlighter, has, where is it defined? It has that again. And then it also, in my opinion, has the most complicated math instruction word that exists. Simplify. It's kind of ironic that I think the most, because it means so many things. You've learned so many things for simplifying, right? If you have 2x plus 3x, simplify means add like terms. If you have 5 over 10, simplify means reduce to lowest terms. And now we're going to add new definitions for simplify with square roots. For almost every single math thing there is, simplify means something specific for that, which makes it a very complicated word. Okay, so let's start with A. Let's do the defined part first. It's a square root. You know you can't square root negative numbers. Will there ever be a problem in this one?
No.
No problems, so then we can say A can be everything. Simplifying. Okay? With simplifying, we're going to simplify the number and also simplify the variables. With simplifying the 45, and I'll write it up right here first, and then underneath, I'm going to be like, hey, I can break up 45. If I can break up 45 so one of the numbers is a perfect square, 9 times 5, then I can change it to a mixed radical. Here's the first rule for simplifying in radicals. A simplified radical is the mixed radical, not the entire radical. Okay, there's a new rule for simplifying. Okay? So we want to write this as a mixed radical. Can you square root a squared? Absolutely. Some of you are going to skip this step and do it in your head. Some of you are going to want to write it out. Anything we can simplify, we write out in front. Square root of 9 is 3. Square root of a squared is 8. Close. Very close. And we talked about this a little bit in the absolute value bar stuff. Right? Technically, the square root of x squared isn't just x. It's the absolute value of x. Because if I had a negative number in here, it would still be 3. Square roots always come out as a positive number. So if I just write a, I might be making a mistake. If a was negative 2, it would become positive, and then when you squared it, it would become positive 2. So we write the absolute value of a, and then what's left in our square root?
5.
Just the 5. Whew.
It's a lot of symbols.
That is a lot of symbols. Okay?
Lots of symbols.
Lots of times you'll see people make this
Why
mistake.
should I do that? It's not simple. I
It
was
looks
happy with 45.
like this looks more simplified than all those symbols,
Yeah.
doesn't it?
And
Yeah.
then aren't the exponent and the square root canceling out each other? Because we square root
With here and
square
here,
root 8, yeah.
they are, but you need the absolute value. Because if I do the square root of negative 3 squared,
Yeah.
an intermediate step would be square root of 9, and the square root of 9 is positive 3. So if we just get rid of the squared, we might make a mistake with the sign. Just to confuse you, right? So this is simplified with a whole bunch of more complicated stuff. Yeah, beautiful. You should see some of the simplified stuff that we do. We're going to start off with something that looks really nice and end with this big thing and say, here is our simplified answer. Okay, our B. Square root of negative 27b to the 9. You see the negative inside the square root? Is this never possible? Or is it sometimes possible? Where is this defined? Okay. Can you tell me a number for b that is good and a number for b's that are bad?
Any negative number.
Any negative number will be good, right?
Yeah.
So then we would say it's defined when b is less than or equal to 0. Any positive number would be bad. Because if you put a negative 1 in to the power of 9, will still be negative 1. Times by the negative 27 will make positive 27. And then you can square root it. Okay. Now, I'm going to write the next step in green, being that if you can do it in your head, perfect. If you want to see it, that's fine as well. Okay? Or I guess it's not green. That looks blue to me. That's right. I picked up the black pen and it ended up not being green. It was blue. Makes perfect sense. Like simplify. Okay. 27. Is there a nice number, perfect square that hits 27? 9 and 3. So I can do 9 and 3. I'll write the 3 as negative 3 in brackets. And then the b to the 9, I'm going to write as b to the 8 and b. Because if it's an even number, you can bring it out in front.
So is doing all of this, like on the bottom in the blue, the same thing as individually putting the square roots on the
Like,
black?
yes.
Yeah.
I could either do it individually. Sometimes when you do it individually, I feel like it, sometimes you can either do it individually or you can write it all underneath.
Okay.
Okay? Now, which one of these, okay, I'll write the equal sign. Which one of these can I do? I could do the 9. That would come out. Square root of 9 is 3. I can do the b to the 8. Square root of b to the 8 is b to the 4. And I don't need the absolute values because the 4 would make it positive anyways. Oh, this is complicated. Lots of thinking. What's left inside? I still have the negative 3 and 1b. Yesterday you said, oh, square roots seem really easy, and now we've like upped the level, right?
Yeah.
Yeah.
If B4 just makes everything positive anyway, why do we need, it's just essentially the same B squared. Like,
Well, no, because 3 squared is 9, and 3 to 4 is 81.
no, I know, but that's
Yeah.
not what I'm saying. That it makes it positive anyway, so why
Right,
do you need
but
the
they-
absolute value?
The absolute value in the previous one, it's just an 8. It's not squared. So 8 could be positive, could be negative.
Yeah.
It has to be. So if it was an odd number, like if this was a b to the 6, and we brought out a b cubed, you would need to have the absolute values
That's,
on that.
when it's an odd number, that's when you bring up the
Yeah.
absolute values, okay.
Okay. Next. C. Here, let's circle our simplified answer. There's our simplified
That's
answer.
so simple.
I like C. Okay, we'll start. We'll write out the question first, and we'll do where is it defined. Okay, we have a fourth root, so that means it can't be negative. Any values of z that you can see being bad? When z is negative, it's going to be bad, right? So then, what's going to be where it's defined, where it's good? Z has to be bigger than or equal to 0. Simplified. Think of your powers of 4. Your first one, 2 to the 4, is 16. That's already bigger than 7. There's going to be no nice numbers that simplify 7. With the variable, if you have a power of 4, you would need at least 4 z's to pull one out. Right? Like if I had, just off to the side, just to show you, if I had a z to the 5, I could pull out one z and be left with 1 then. With the 4th root, you need 4 of them to pull 1 out. Squared, you need, like, with the 8, when we had squared, you need 2 of them to pull 1 out. When I have 8, I could pull out 4, because every 2 pulls 1 out. Okay? With the 4th root, you need 4 to pull 1 out. With the cube root, you need 3 to pull 1 out. So let's just do, let's have fun here. Let's do the 5th root of a to the 32. How many can I pull out? 6. How many would I have left? 2. That's simplified. Okay? So the mixed radical is simplified, and now we're adding variables and numbers at the same time. So to simplify this one, you can't do anything. It is already simplified. Wouldn't that be the nicest question on a test to just drive you crazy? It says simplify, and all the work you have to do is to do nothing? Oh my goodness. That would be like, I feel really confident now. I did nothing on this question and I got it right. Okay. And then part D. Cube root of 24y to the 5. Cube root of 24y to the 5. The index is negative. This is the easiest one to do to find. I mean, the index is an odd number, sorry. The index is an odd number. This is the easiest one because positives work, negatives work, 0 works, everything works with an odd index. So it's defined for everything. Now again, this blue step, with the cube roots you might want to do this, okay? 24, in your powers chart, is there any perfect cube that divides 24? Don't do 4 and 6. 4 is a perfect square. 12 is not a perfect cube. 8. Really have to know our times table, so I'm going to go 8 times 3. I need 3 of them to pull 1 out. So I'm going to change my y to the 5 to y cubed and y squared. Cube root of 8. Out would come a 2. The cube root of y cubed is a y. No absolute values needed because it's a cube root. Odd roots, don't have to worry about that absolute value. It's only with even roots. And then what's left inside? I'm left with the 3 and the y squared. This is considered simplified. Right? And you're like, they both look complicated to me.
Could you explain that again?
Yes. So what we can cube root is the 8 and the y cubed. So the cube root of 8 is 2. The cube root of y cubed would be y. What are we left with inside? We're left with the 3 and the y squared afterwards. So we pull out the ones we can cube root, and we leave what we can't inside. And once it's in lowest terms, you're set. Can I give you a tricky one?
No.
Tricky but easy, mental math. Okay? Tricky but easy, mental math. I'm going to show you it and see if you think I did a good job. Okay? Square to 7. I'm good at my times table. Oh, this is the step that I said we can do in blue. I'll do it in blue just in my head. 9 times 8. Don't have to show that if you don't want to. How did I do? Pretty good?
Yeah.
Good? It's not right.
You can simplify 8 more.
You can simplify 8 more. Oh my goodness. Right? Because 8 Oh, this is blue step. You don't. That's 4 times 2. So I could bring out the 2. 2 times the 3. This would be 6 root 2. Wouldn't it have been nice had I thought of 36 times 2 instead of 9 times 8?
No.
Oh, it would have been so much easier if I had done that to get to 6 root 2 right at the beginning. But it's not wrong if you do 9 times 8. But it's easier if you see the biggest one first. 72 divides by 9, perfect square. It also divides by 36, perfect square. So even once you think you've simplified, you should check if you can simplify more. Did I give you questions on the last one? On number 3?
No.
Okay, for number 3, circle question 6. And for number 4, circle 10, 11, and 14. And enjoy the word simplify.